Hello and welcome to Mech Zone. Previously we have started off with the first chapter of Theory of Machines, and that was Kinematic Links and Mechanisms. And we have already discussed about the various aspects on different types of pairs, then classification of links, and we also saw that the different types of motions, that is the completely constrained, successfully constrained and the incompletely constrained motion. Now from this lecture we shall be discussing about the different types of pairs or joints. Different types of pairs or joints. Okay, now the first type of joint that we will discuss is a binary joint. So as the word suggests, binary, the root word bi is actually meaning two. So here two links are joined. Okay, the two links are joined. For example, this is the first link, this is the second link. So this becomes a binary joint. And in case of a slider mechanism, slider is the first link, this is the second link. So this is also actually an example of binary link. Other example can be like this. This is the first link, this is the second link. So this becomes the binary joint, where actually two links are joined at one point. And slider is also behaving like a binary joint. We should remember that slider is also actually behaving as a binary joint. The next type of joint is the ternary joint. So as the word suggests, ternary is a type of joint where three links are connected. The point where three links are connected becomes a ternary joint. For example, this is link number 1, this is link number 2, this is link number 3. So this becomes the ternary joint. And another example, this is link number 1, this is link number 2, and this is 3. So this becomes a ternary joint. Okay. Now if we look in this particular example, then 1 2 2 3 1 3 are the different types of binary joints. There is a joint between 1 and 2, 1 and 3, and 2 and 3 also. These are individually binary joints, and out of these three combinations, 2 are independent and 1 pair is dependent. So actually one ternary joint can be equivalent to two binary joints. Now since one of the pairs will be dependent and other two will be independent, and hence one ternary is equals to two binary joints. This is an important discussion here. And only independent joints are considered. The dependent joint is not considered, and hence we are getting one ternary equals to two binary. The third type of joint is quaternary. Quaternary joint. In case of the quaternary joint, four links are joined connected at a point. For example, link number 1, 2, 3, 4. So if we form the pairs, it will be 1 2, 1 3, 1 4, 2 3, 2 4, 3 4. So total number of pairs can be obtained by the formula NC2, and hence out of 1 2 3 4 5 6 pairs, the 3 are dependent and 3 are independent. So the number of independent joints are actually considered and the dependent will not be considered. Hence one quaternary is equals to 3 binary joints. So this is also an important point which needs to be remembered. So one ternary equals to 2 binary and one quaternary equals to 3 binary joints. Next we will discuss about the kinematic chain. So in case of a kinematic chain, if all the links are connected in such a way such that the first link is connected to the last link in order to form a closed chain. So important points are: closed chain should be formed and the first link should be connected to the last link. And if all these conditions are satisfied, then we are going to say then it is a kinematic chain. Okay, and if all the relative motions in this chain are constrained, and if it is in this chain all the relative motions are constrained, then the chain is called as a kinematic chain. Kinematic chain. So kinematic chain, all the motions are, relative motions are constrained. Okay, so in a kinematic chain, what we are doing is we are fixing one link. If we fix one link in order to use this chain, so if one of the links is fixed, then what will happen? It will become a mechanism. It will become a mechanism, and this mechanism can be easily used in any particular machine where we are getting a desired output, corresponding to a unique input. So this is a very important statement, that machines are always designed for one-to-one function. That means for one input there will be a particular one output, and hence their degree of freedom is 1. This is very important. All the machines are designed on the basis such that their degree of freedom is 1. It means that for correspondingly one input there will be a one unique output. Okay, and the desired output is obtained. So this was about basics of mechanism. Now the word that I have discussed, degree of freedom, we shall be discussing it right now. Now we come to the topic of degree of freedom. So degree of freedom we have already discussed in thermodynamics, and it is the minimum number of independent variables. Please mind, it is also called as mobility. It is also called as mobility, and it is defined as the minimum number of independent variables which are required to define the position or motion of a system, and it is called as the degree of freedom. So in TOEM, the position and motion are analogous. The position and motion are actually considered to be analogous. Okay, now if we talk about space, if we talk about the space, z-axis, y-axis, x-axis, if there is a cube, now for this cube we can have one motion in this direction, other motion in the x direction, other motion in the y direction, and consequently we can also have rotations along these axes also. So for 3 translation and 3 rotational, we are total getting 6. 6 is the maximum number of motions. Maximum number of motions. Okay, so degree of freedom actually becomes 6 minus number of restraints that can be put on the system. So this is a very, very important formula. So number of restraints, what do we mean by number of restraints? Number of restraints simply means that these are not permissible motions. These are not permissible motions. So we are going to deduct those motions from 6, and hence we will obtain the degree of freedom. Okay, now if we talk about the rotation, and we have to keep in mind that rotation is always taking place in a particular plane. Okay, rotation is always taking place in a particular plane. Now if we see the different types of pairs, their restraint and the degree of freedom, it is abbreviated as DOF. So if we are having a pair like this, links 1 and 2, then it will have 3 translation and 2 rotation. Total is 5. So degree of freedom would be 6 minus 5, it is equals to 1. Okay, now for example, if this is a plate and a spherical ball is kept on this plate such that the plate is link 1 and the sphere is plate 2, it will have only one translational motion, and hence the degree of freedom becomes 6 minus 1 is equals to 5. Okay, now this is a very important case. This question was asked by one of our students in the PSU interview when he was there for BHEL, and he was asked about this question. So this is very important. Okay, so lower pairs, if we talk about lower pairs, they generally have 1 degree of freedom. Lower pairs generally have 1 degree of freedom, but there is an exception that the spherical pair actually has 3 degree of freedom. So we have to remember this exception also. In case of a spherical pair, we have 3 degrees of freedom, whereas normally all the lower pairs will have 1 degree of freedom. Okay, so if it is having 3 degrees of freedom, then what would be the number of restraints? Number of restraints would be 3, because 6 minus number of restraints becomes the degree of freedom. So here the number of restraints becomes 3. So the question can be asked in the either way, and it can be also asked in a twisted manner. However, for the higher pair, it will have 2 degree of freedom. It has 2 degree of freedom. Okay. Now, for example, if we take x-axis, y-axis such that there is a block, it can go in this direction, it can go in this direction, it can have a rotation like this. We are actually considering the 2D case. This is not a 3D case, please mind here. So here we can have 2 translation and 1 rotational motion which are possible. Let L is equal to the number of links, J is the number of binary joints which are present, H is the number of higher pairs. Okay, and if one link is fixed, if in a system one link is fixed, then what will be obtained? L minus 1 links will be considered. If one link is fixed out of the n links, then the number of links available for analysis would be L minus 1. So there was a scientist, his name was Kutchback, and he gave his equation, Kutchback equation, to find out the degree of freedom for 2D structures. Please mind, he gave his analysis only for 2D structures, and the degree of freedom F was 3 into L minus 1 minus 2J minus H. This is known as the Kutchback equation, and by using the Kutchback equation we can easily find out the degree of freedom of a planar mechanism. Please mind, there are 2 important points, that is planar mechanism and 2D structure. It can only be used for planar mechanisms and 2D structure. Okay, where 3 into L minus 1 is actually representing the number of maximum motions, in 2D planar mechanism. Okay, so in the Kutchback equation we have to keep in mind what are the different terms representing. So this equation is mainly used to find out the degree of freedom of the 2-dimensional structures. However, later on a modified version of this equation was also introduced, modified form, and in the modified form we had F is equals to 3 into L minus 1 minus 2J minus H minus FR. Now this FR term was introduced here. It is actually the number of those motions which are not a part of the mechanism. These are called as redundant motions, and these redundant motions are not the part of the mechanism. They neither depend upon input, or on output. So these are not dependent on input, or they are neither dependent on output. Now we will see where can we find the examples of such redundant motions. For example, we have a rectangular groove such that there is a bar inside this groove. Okay, this link is fixed. Say this is link number 1, this is link number 2, this is link number 3, this is link number 4. Now the rod can move independently inside this rectangular groove. First of all, we will find out the number of links. So the number of links is 1, 2, 3 and 4. Then we will find out the number of joints. For number of joints, I'll tell you a very simple trick. One link and the two link joined here, one joint. Similarly, second joint, third joint and fourth joint. So number of joints are 4. Now we will find out whether there are any redundant motions or not. We find that there is one redundant motion. That means by moving this link, it can be moved, or this link can be moved independently. The link 4 can be moved in the rectangular groove independently. So redundant motion is 1. Higher pair is 0. We do not have any type of higher pair here. So if the degree of freedom is evaluated, then 3 into L minus 1 minus 2J minus H minus FR. If we keep these values in this equation, we would find the degree of freedom is 0. Degree of freedom is 0 means the mobility is 0. So this was the first example. Now we talk about the second example. Like this. This is exactly the same example that we have discussed in the previous example, but it is a bit quite different. Link 1, 2, 3, 4. Now we see that the link 3 cannot be moved independently in this groove. Okay, so FR actually becomes 0. Number of links are 4. Number of joints, binary joints are 4. Higher joints is 0. So if you calculate the degree of freedom, it would come out to be 1. So in this case, this link 3 cannot be moved independently in this groove. The third example is of cam and follower. We will be studying the chapter on cam independently. We are only discussing some of the examples here. Okay. The ground is always considered as the link 1. We will always consider the ground. This is the link 2, that is the follower link. The third link is the link between this cam and this point. This is called as the third link. And this is actually the fourth link. Okay. This is also considered in the ground link only. So this is actually link third. So if we look at the number of links are 4. The number of joints would be, this is a binary joint, this is a binary joint, and link joint between 1 and 4 is a binary joint. The number of binary joints are 3. Now if we look at higher pair, we will find that the point here, it is actually a higher pair because it is making a point contact. So higher pair becomes 1. There is one redundant motion. Now many people will be confused how we will get one redundant motion. For example, if we remove this follower part, the cam can be moved independently. It is simply compared to a pizza cutter. अगर आप pizza cutter को देखें तो pizza cutter की भी blade को हम लोग ऐसे घुमाते हैं तो वो rotate individually कर सकता है. तो same is being compared here. So and hence the redundant motion is 1. Thus if you find out the degree of freedom, it would come out to be 1. And to your utter surprise, this is always 1. Degree of freedom in case of cam and follower mechanism, whether it is a roller follower, whether it is a knife edge follower, it is always coming out to be 1. The fourth example we would discuss of a knife edge follower. So okay, this is the follower, this is the knife edge follower, and this is actually the cam. Here it is also a follower. This is a roller follower. In the previous lecture I may have said that this is cam and this is the follower, but it is not. It was a mistake. So this is the cam and this is the follower. So here we are getting a roller follower, here we are getting a knife edge follower. This is grounded. So this is link 1. This is link 2. There is a link between follower and the cam. This is called as the link 3, slider link. Okay. And this is link number 1. Here we are not having 4 links. We are only having 3 links. Okay. and this third link is actually the link between the follower and the slider. Here we have taken it as 4 and here only 3 links will be present. So number of links present are only 3. Number of joints present would be, one joint would be present here and another joint would be present here. So number of binary joints would be 2. Higher pair, here we are having a higher pair. So higher pair is actually 1. FR, redundant motion, here it is 0. We are not having any redundant motion. Okay, this is important. So if we find out the degree of freedom, still it would come out to be 1. So if it in the examination you are not sure which answer to mark, then you can take a chance and you can also mark option number 1, because in almost 99% cases cam and follower mechanisms we are getting the degree of freedom to be 1 only, and cam and follower mechanisms always have degree of freedom equal to 1. Okay, now some important points about the degree of freedom. We will discuss some important points about degree of freedom. For example, if the degree of freedom is coming out to be 0, then it means your mechanism becomes a frame or a structure. It is a frame or a structure, and hence it will have no relative motion. It will have no relative motion. Okay. For example, if we are having this type of mechanism such that this link is fixed, link number 1, link number 2, link number 3. So number of links are 3. Number of binary joints, 1 joint, 2 joint, 3 joints. So number of binary joint is 3. Higher pair is 0. FR is equals to 0. So if you calculate F is equal to 3 into L minus 1 minus 2J minus H minus FR, it is coming out to be 0. Therefore this becomes a frame or a structure. Next case, if the degree of freedom is less than 0, that means it is getting a negative value. For example, minus 1, minus 2 and so on. If the degree of freedom is less than 0, then it will become a superstructure. It becomes a superstructure or indeterminate structure, or it is also called as indeterminate structure. Okay, so here in case of the indeterminate structure, the number of unknown parameters will be greater than the number of equations which will be available. So we have to use a compatibility equation like the one that we have discussed in the strength of materials. Now, for example, this is link number 1, this is link number 2, and we are joining another link, say like this: 1, 2, 3 and 4. So the number of links are 4. Number of joints, if we count, this is a joint, this is a joint, this is a joint, this is a joint, and this is a joint. See, this is one complete link. Some people will think that this is one link, this is another link, this is another link, so this becomes a ternary joint. No, this is one complete link. This is also one complete link. Okay, so the number of joints becomes 1, 2, 3, 4, 5. FR is equals to 0. Here we have no redundant motion. Number of higher pair is equal to 0. So correspondingly, if you find out the degree of freedom, it is coming out to be minus 1. And negative degree of freedom indicates that the mechanism is actually having more amount of strength. It is having more amount of strength. The third case is if the degree of freedom is equals to 1. If the degree of freedom is equals to 1, then it is called as the kinematic chain. It is called as the kinematic chain. For example, link number 1, 2, 3, 4. Number of links is equals to 4. Number of binary joints 1, 2, 3, 4 joints is equals to 4. Higher pair is equals to redundant motion is equals to 0. Both are 0 here. So if you find out the degree of freedom, it is coming out to be 1. Hence it becomes a kinematic chain. Okay. The fourth case, if the degree of freedom becomes greater than 1, like 2, 3 and so on, then it is called as the unconstrained chain. If somehow the degree of freedom becomes greater than 1, then it is called as the unconstrained chain. For example, we are considering this example, like a link in the shape of a pentagon. 1, 2, 3, 4, 5. Now if we wish to find out the number of links, L would be equal to 5, J would be equal to 1, 2, 3, 4, 5. J is also 5. H is equals to FR is equals to 0. So F, if we calculate, it is coming out to be 2. So we always have to check if it is in a case of cam and follower, then always check whether there is a redundant motion or of the roller or not. So the degree of freedom here is coming out to be 2. Now I will tell you a very important statement about the degree of freedom, and that is the degree of freedom is the number of input which is required to get a constrained output. This is a very simple statement that can be used for the degree of freedom. The degree of freedom is the number of input required to get a constrained output. Okay, now we will do some examples where we will try to find out the degree of freedom of the given systems. So this is the example where we need to find out the degree of freedom. So in the current diagram we can see the number of links are 10 in number. Now we will find out the number of binary joints. See, at this point 3 links are connected, 1, 2 and 3. So it becomes equal to 2 binary joint. Therefore I am putting 2 dots here. 2 dots means 2 binary joint. Here there is only 1 binary joint. On this point we have 1, 2 and 3. 3 links are connected, so it is equivalent to 2 binary because this becomes a ternary joint, hence it is equal to 2 binary joints. At this point also we are having 1, 2, 3 links, so it also becomes a 2 binary joints. Same is the case for here, 2 binary joints. Same is the case for here, 2 binary joints, and this place also we are having 2 binary joints. Now we will count the number of red dots. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the number of binary joints are actually coming out to be 13. Higher pair is equals to 0. Redundant motion is equals to 0. And hence the degree of freedom is coming out to be 1. Since the degree of freedom is 1, we will say that it is a kinematic chain. Now how this example can be modified, and it can be asked, for example, if in this example we consider this as one chain, if this part is considered as one link. Now in the above example what we have done is we have considered this part as one complete link. Now the number of links, if we will count 1, 2, 3, 4, 5, 6 and 7. So the total number of links are 7. Now we will count the number of binary joints. Now since this point is having 3 links, so this is a ternary joint, hence it is equivalent to 2 binary joints. Here we are having only 2 links, so this is 1 binary joint. This becomes a ternary joint and hence it is equivalent to 2 binary joints. Now this point is actually connecting link number 3 and link number 2. So since this is considered as one entire link, so this becomes a single binary joint. This also becomes a single binary joint. This also becomes a single binary joint. This is also considered as a single binary joint. Now we will count the number of red dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of binary joints are coming out to be 9. Higher pair is equals to 0. Redundant motions are equal to 0. And if we find the degree of freedom, it is coming out to be 0. Now since the degree of freedom is coming out to be 0, it becomes a frame or a structure. And here the degree of freedom is 1, therefore it is a kinematic chain. Okay. Now we will discuss another important example. Now this is a very important example that can be asked in GATE 2018. So kindly pay attention towards this diagram. अगर मैं कुछ भी कैलकुलेशन नहीं करूं, सिंपली अगर देख कर भी बताऊं, मतलब अगर इसे देख भी लूं, तो मैं ये डायरेक्टली बोल सकता हूं कि द डिग्री ऑफ फ्रीडम इज ओनली 1 इन दिस केस. कहां देखा है आपने इस टाइप का मैकेनिज्म? मेले में एक सांप मिलता था जिसमें डंडी लगी रहती थी, तो उसको जब हम लोग ऐसे ऐसे करते थे तो सांप आगे जाता था, आपको याद होगा. ये सेम वैसा ही मैकेनिज्म है. दिस मैकेनिज्म इज सिमिलर टू दैट स्नेक दैट वी यूज्ड टू बाय ड्यूरिंग द मेलास. एंड उसका सिर्फ एक ही मोशन था, वो आगे या पीछे, बस एक ही लाइन में आगे रेसिप्रोकेट कर सकता था. तो वहां से सिंपल तो हम ये बता सकते हैं कि डिग्री ऑफ फ्रीडम हमेशा ऐसे में 1 ही होनी है. हाउएवर एक और एग्जाम्पल है जहां पर डिग्री ऑफ फ्रीडम 1 नहीं थी, वो आपका रतन में दिया हुआ है, तो वो एक डिफरेंट केस था. लेकिन जनरली ऐसे मैकेनिज्म्स में डिग्री ऑफ फ्रीडम 1 होगी. सबसे पहले वी विल काउंट द नंबर ऑफ लिंक्स. तो देखिए, एक लिंक तो हो गई आपकी स्लाइडर और ये वाली, इसको मैंने 8th लिंक बना दिया. फर्स्ट लिंक इज बिटवीन द स्लाइडर वाली, तो अपनी एक लिंक हो गई, और स्लाइडर और ये 3rd लिंक के बीच का जो लिंक है दैट इज कॉल्ड एज द 8th लिंक. ये पूरा 2nd लिंक, ये पूरा 3rd लिंक, ये पूरा 4th लिंक, ये पूरा 5th लिंक, ये 6th हो गया और ये 7th हो गया. ठीक है, तो टोटल नंबर ऑफ लिंक्स बिकम्स 8 इन नंबर. नाउ वी विल फाइंड आउट द नंबर ऑफ बाइनरी जॉइंट्स. ठीक है, तो सबसे पहले तो एक जॉइंट यहीं पर हो गया, एक ग्राउंड वाली लिंक, ये 1 लिंक होती है, और ये हो गया यहां पर. दूसरा बाइनरी जॉइंट कहां हो गया? एक तो आपका बाइनरी जॉइंट होगा स्लाइडर वाला 1 नहीं, मुझे डॉट बनाना चाहिए एक्चुअली. डॉट मतलब बाइनरी जॉइंट जो स्लाइडर में होगा, और एक इस पॉइंट के करस्पॉन्डिंग भी आपका बाइनरी जॉइंट हो जाएगा. ठीक है, और ये लिंक और ये लिंक इस पॉइंट पर है. दिस ऑल्सो बिकम्स अ बाइनरी जॉइंट, दिस ऑल्सो बिकम्स अ बाइनरी जॉइंट, दिस ऑल्सो बिकम्स अ बाइनरी जॉइंट. ये भी है आपका एक बाइनरी जॉइंट, क्योंकि ये वाले लिंक और ये वाले लिंक आर अटैच्ड एट दिस पॉइंट. तो 2 ही लिंक है, एक ये कंप्लीट लिंक और ये कंप्लीट लिंक. आप यहां पर 4 लिंक ना माने, 1 2 3 4 लिंक्स नहीं है, पूरी लिंक नंबर 5 एंड पूरा लिंक नंबर 4 आर अटैच्ड एट दिस पॉइंट. एक ये भी पॉइंट हो गया, एक ये भी पॉइंट हो गया. नाउ वी विल काउंट द नंबर ऑफ बाइनरी जॉइंट्स. 2 joints are at this place, 3, 4, 5, 6, 7, 8, 9, and 1 joint, binary joint is also present here because it is connecting link number 3 and link number 2. So if we count 2 binary joints at this point, 1, 3, 4, 5, 6, 7, 8, 9 and 10. So the number of joints are coming out to be 10. Higher pair is equals to 0, redundant motion is equals to 0, hence the degree of freedom is coming out to be 1. So this is a very important point, and we have to note one point here, that the number of lower pairs would be equal to the number of binary joints. The number of lower pairs would be equal to the number of binary joints. So with this we come to the end of our lecture. In the next lecture we shall be starting with the analysis of Grubler's equation. So I hope कि आपको हमारे lectures पसंद आ रहे होंगे. तो हमें अपना valuable feedback हमारे channel पे या हमारे Facebook पेज पर आप हमें दे सकते हैं, हमारे साथ अपनी प्रॉब्लम शेयर कर सकते हैं. सारा स्टडी मटेरियल एब्सोल्युटली फ्री ऑफ कॉस्ट अवेलेबल है, वो आप हमारे इस वीडियो के डिस्क्रिप्शन सेक्शन से भी डाउनलोड कर सकते हैं. हमारे चैनल के बारे में अपने फ्रेंड्स और कलीग्स को बताइए ताकि उन्हें भी बेनिफिट मिल सके. बिकॉज जिस कोचिंग के लिए हम मतलब बीटेक के बाद लोग मेडीजी और एस जाते हैं, बहुत कॉस्टली कोचिंग्स हैं, हर कोई अफोर्ड नहीं कर सकता. वो सारा मटेरियल हमारे चैनल पे फ्री ऑफ कॉस्ट अवेलेबल है. तो हमें अपना वैल्यूएबल फीडबैक देते रहिए, हमारे साथ अपनी प्रॉब्लम्स भी शेयर कीजिए. सो थैंक यू फॉर टुडे.